Okay, so getting back to page 9, this is week 3, the first free response. We had gone over why a is negative 2 and 0, right? That's because that's where we have a min and a relative max on the function, and our justification is because f prime changes from increasing to decreasing or vice versa. That's quote-unquote the easy part. Now we're going to go ahead and talk about the hard part, part B, where we have to actually calculate f of negative 4 and f of 4. So my calculation for f of negative 4 is going to include the definite integral, right? I'm going to choose negative 4 as my lower limit. I have to choose 0 as my upper limit because that's my initial condition. The area under the curve is equivalent to, I'm going to write a fundamental theorem. I'm going to finish this off, right, with an f of 0 minus f of negative 4. Okay, and this is my variable right here. Okay, so I'm going to find the area under the curve from negative 4 to 0. So that is under here, from here to here. So basically I have this rectangle here, which has 8 units of area, minus the semicircle would give me this area underneath it. And the area of this semicircle is pi times 2 squared all over 2. Radius is 2, divided in half because it is a semicircle. So that is 2 pi, right? So this side is worth 8 minus 2 pi. This is worth 5. And then minus f of negative 4, that's my variable, right? So if I'm going to solve for this, I'm basically going to subtract 5 and get 3 minus 2 pi equals f of negative 4. It's actually equal to the opposite of f of negative 4, right? And then divide by negative 1 gives me 2 pi minus 3 for f of negative 4. Okay, so that's a straightforward, using geometry, you can actually calculate the area under the curve. For the other half of this, right, it wants f of 4. And you're going to set it up the same way, but your calculations are different. So f of 4 is going to be the area from 0 to 4 under the same curve. That's equal to this fundamental theorem statement, right? F of 0. Okay. But when we calculate this side this time, we actually have to get the value of this integral, right, from 0 to 4. So I'm actually going to have to integrate this function. So this is going to be a little bit of no fun. But this part, just in and of itself, f of 4, is 3 points. Okay, so that's why it's a little bit harder than the first calculation. So this is what my left side is going to become. I have to keep integrating this, right? So if you remember, the shortcut for integration is, since this is a fraction, negative 1/3 is the coefficient of x. I'm just going to take 5 and divide it by negative 1/3 for integration, which gives me negative 15. So this is the antiderivative of the first term, minus 3x from 0 to 4. Okay, and then I'm going to do negative 15 e to the negative 4/3 minus 12 minus, in parentheses, negative 15 e to the 0 minus 3 times 0. Okay, be very careful with these outside parentheses here. So I've got negative 15 e to the negative 4/3 minus 12. This is plus 15. And all of that is equal to f of 4, which is my variable, minus 5. Okay, so now I'm going to add 5 to both sides. I get 20 minus 12 is 8. So it's negative 15 e to the negative 4/3 plus 8. That's my answer for f of 4. Okay, a little bit difficult on that, but if you can at least write this down and maybe sub in some values, you can get partial credit if you can't see that all the way through. Okay, and then part C, probably you're better at now. Which value does f have an absolute maximum? Justify your answer. So we have to look at where f prime changes from positive to negative for an absolute max, right? Does that ever happen positive? Okay, so I've got choices of my endpoints, negative 4 and 4, and then at 3, ln of 5/3, right, for f. Okay, so f of negative 4 we calculated, right, that's 2 pi minus 3. F of this guy, we'll have to think about what that is in a sec. F of 4 is 8 minus this. This one's really hard to do without a calculator. And then I guess 3 ln of 5/3 is basically going to be this answer, 2 pi minus 3, plus whatever this area estimate is of this triangle right here, right? Because that's an accumulated area under it. So I think this is going to be our absolute max there. So the way that it's stated here, right, find the value at x at which f has an absolute max. So I'm going to say x equals 3 ln of 5/3 because f of 3 ln of 5/3 is greater than f. I guess you have to compare it to this guy because this one, yeah, 2 pi minus 3. Well, I would just say that it's greater than both of them, f of -4 and because f of 3 ln of 5/3 is greater than f of 4. Okay, that should get you full credit. You could estimate this to be, what, 1/2 base times height for this triangle. 1/2 base is 1.5. Height is 2. So you could estimate that to be, another 3/2 roughly here. So that's why it's greater than that one. Okay, very tricky part C2. All right, and then number 10, this is another amusement park problem. This one has to do with getting on the roller coaster. Roller coaster, right? We've got a graph that we're looking at here. It says that there are 700 people in line when the ride begins operating. Once it begins, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move on to the ride at a rate of 800 people per hour. The graph is the rate at which people arrive at the ride. So this is the rate that people arrive. You might just write that down here. Arrive in line. T is measured from hours from the time the ride begins. Okay, part A. How many people arrive at the ride between 0 and 3? We're going to use integration there, right? Because they're asking us to calculate how many from 0 to 3. All of this area here. Okay, so just to save us a little bit of time, I'll write the integral down with you. You should write exactly this. And then if you accurately calculate that, right, I think you do get 3,200 people. Okay, so I'm going to let you, when it says show the computations, that means that you have to show, oh, I took this trapezoid, right, 1/2, the height of that trapezoid is 2 times the sum of the bases are 1,000 and 1,200 plus, then I did this other trapezoid. Okay, so you have to fill in that other trapezoid, and they have to see the progression from these values to 3,200. So don't omit that part or you'll lose points. Part B is the number of people waiting in line to get on the ride increasing or decreasing at between 2 and 3. Okay. So between 2 and 3, I think we are looking at what's comparison of the number of people waiting in line. So these is the rate that they arrive in line, and they are getting on at 800 people per hour. Okay, I would probably, if this were me, try to calculate how many people. I would try to come up with maybe like a function that models the number of people waiting in line. So I would call that function P for people, right? P at a certain time. There's 700 there at the start. They are getting there, right, at this rate. So we accumulate the area under this curve that they pictured for us. And then we're losing people in line at this rate, right? So it's important to put the dt here to separate that this is not part of this integrand, okay? So this is how many people are in line at any given time, so I'm trying to figure out if that's increasing or decreasing between 2 and 3. So I would do p prime. The derivative of this is 0. The derivative of this is poor notation. This should say r of x. This should say x. Would be r of t, right, based on the fundamental theorem, minus 800. I'm going to set that equal to 0 for any critical numbers, and basically whenever r of t, which is the picture, is equal to 800, I have a possible maximum value for the time in line. So here at 800, right, this is bigger than that, right, so it's probably going to be at t equals 3, right here, right, that people max out how many are in line. I could verify that, right, by doing an actual test to see at 3. It does go from positive to negative, this function, right? So it looks like that would be the actual, this is the relative max, okay? And so when it asks, is the number of people waiting to get on the ride increasing or decreasing, we're going to say it's increasing because this function that I've decided on p prime of t is positive. So that's based off of this title. Okay, so it's big. It's bigger than 800 up here, right? All of these values are bigger than 800, so it's increasing. Part C, at what time is the wait the longest and how many people are there? So part C, actually what I did in part B is going to come in kind of handy. So if I'm going to try to figure out when it's the longest, I'm going to try to maximize this function, right? Well, I figured out here that there's a maximum there, and I'm assuming that that's going to be the case, right? So let me try to calculate what P of 3 equals and make sure it's actually greater than 700, which of course it has to be. So let's see. 0 to 3 under this curve, minus 800 times 3. So this is 700 plus, these are all the people that I calculated in part A. That's kind of nice. Minus 2,400 people that they got off the ride. So at that time, 39, 1,500 people are there. People. At what time t? At t equals 3, the wait is the longest. Because the largest number of people are in line at that time. So that's what I calculated kind of aggregately, I think, between parts B and C. Oh my God. And then there's a part D. This is terrible because we're out of space. That's why it's helpful to do the work on a separate sheet, right? Write but do not solve an equation involving an integral expression whose solution gives the earliest time when there is no longer a line for the ride. All right, so what is that going to involve? That means that we're going to have to, of course, make this here equal to 0. We want people, the number of people in line to be 0, right? So I'm going to go ahead and just set that particular function that I wrote like 400 times up here. Part D, I want 700 plus 0 to t of r of x dx minus 800x. I want that to, oh, this should be a t. Nice sloppy notation today. Is equal to 0. So it's kind of hard to see probably from way back here, right? But this is how many people are in line. I want that to be none, right? No longer a wait. Okay, so that's why I'm setting that equal to 0. I should be proper back here and make this a t as well. All right, okay.